Problem 11, Solid State Physics. The question is, a tight binding model of electrons in one dimension has the dispersion relation E of k, which is equal to minus 2t 1 minus cos ka, where t greater than 0, a is the lattice constant, and minus pi by a less than k less than pi by a. Which of the following figures best represent the density of states over the range pi by 2a less than or equal to k less than pi by a? We have to find out the correct graph from the four options. First, let us write the equation of density of states, which is equal to dn by de, which is equal to dn by dk, dk by de. Now, we have studied that for one-dimensional case, this dn by dk, which is equal to dn by dk, which is equal to L by pi. Now we have to evaluate dk by de. To evaluate dk by de, use the given expression from the question. It is given that E of k, which is equal to minus 2t 1 minus cos ka. Now find out de by dk, which is equal to minus 2ta sin ka, from which you will get dk by de, which is equal to minus 1 by 2ta sin ka. Now substitute the value of dn by dk and dk by de in the expression for density of states. You will get d of E, which is equal to L by pi into minus 1 by 2ta sin ka, which is equal to minus L by 2 pi ta sin ka. This is the expression for the density of states using the dispersion relation given in the question. Now let us apply the boundary condition. What happens when k equal to pi by 2a and k is equal to pi by a? Let us apply the boundary condition. When k is equal to pi by 2a, we have sin ka, which is equal to sin pi by 2, which is equal to 1. Therefore, the density of states become minus L by 2 pi ta, and which is a finite value. At k is equal to pi by 2a, our density of state d of E, which is finite. Now let us see what happens when k is equal to pi by a. When k is equal to pi by a, sin ka, which is equal to sin pi, which is equal to 0. Therefore, the density of states becomes minus L by 2 pi ta into 1 by 0, which is nothing but infinity. So, we have when k is equal to pi by 2a, our density of state is finite, but when k is equal to pi by a, the density of state is infinite. Now, using this idea, we can see that from the given option, option B is the correct option.